yeah, now final sprint, I would say. The topic of the last part are auto-reclosure with secondary arc detection and measured voltage failure detection.
All right. Welcome back. Thank you for being so patient. Let's get into this interesting subject. It's auto-reclose, but I'm going to focus very much on the secondary arc detection, which is a very, very interesting feature we have. The auto-reclose in general, trying to keep it brief, is done in the following manner: that you have a short circuit, right, which will have a fairly large primary fault current, and then depending on your application, you have then a 1-pole trip or 3-pole trip. This is done by the protection, and the auto-recloser is always started by a protection trip. This is just the definition of that. Then two things can happen after the trip, okay, either 1-pole trip or 3-pole trip, it doesn't matter. It is either a permanent fault or an arc fault, okay. If we're on the 3-pole tripping side, then the secondary arc detection does not apply. The secondary arc detection only applies to the single-pole tripping. But remember, single-pole faults are approximately 80% of the faults on an overhead line are single-phase faults. So the single-pole auto-reclosure is a very effective means to get good system availability. So if we stick to the single-pole tripping side, then you see the two conditions, the permanent fault and the arc fault. If it's a permanent fault, then at the bottom what would happen, the auto-recloser would come and it would not be successful. So you would reclose after the 1-pole dead time, and you'd have to then trip 3-pole, and it will be not successful. If it was an arc fault, basically a transient fault, then that arc would typically extinguish during the dead time if the dead time is sufficiently long and the coupling and the system conditions allow for that, and you reclose after the extinguished arc, then you have a successful auto-reclosure. If obviously the arc is not extinguished, again you would have a non-successful auto-reclosure. Those are the conditions. Now that is just classic auto-reclosure. How can the secondary arc detection improve on that? And we'll have a look at that later on. So first of all, the advantage, I think we had the question earlier. Yes, auto-reclosure is a big advantage for system availability, and the 1-pole even better, because during a 1-pole dead time you don't have loss of synchronous power flowing, so system stability is much improved. That power swing stuff we spoke about earlier is not going to be that apparent. If you have a 1-pole trip, the risk of a power swing is much less than if you have a 3-pole trip after a fault. Technical challenges for the 1-pole auto-reclose is obviously you need to set a dead time that's sufficient for the secondary arc. Now we'll expand the secondary arc just now to disappear. And the probability of an unsuccessful 1-pole auto-reclose is if the set dead time is too short, because then the arc has not got enough time to extinguish. If it's very long, then you have an unnecessarily long dead time. But there are a technique to improve on that. And that technique is the secondary arc detection. But before we get there, let's just briefly look at the 3 stages of a typical single-pole auto-recloser. The first stage is the fault over there. As I said, fault current, a large fault current protection relay is operating, gives a trip command. The trip command will be then followed by the breaker opening. So we go into from the auto-reclose point of view into the second state is when the breaker is open. Now we have the 1-pole dead time. And I'm going to assume that the remote side has done the same thing. I'm not going to worry about any inconsistencies. So both sides have a 1-pole dead time. Then you are in this middle condition. And this is very interesting because now you can see I draw the capacitances in here. The healthy phases, the top 2 in this case, will couple via capacitance to the open pole, that both sides are open, and there will be a continued current flow via the arc. So remember, the arc was there from the fault condition at the beginning, ionizing the air. Remember that 2.5 kilovolt per meter and a large fault current, and a lot of, you've seen some videos of this, like really magnificent arcs. That does not go away very quickly. We are talking here sub 1 second, and that's a fairly short time for this gas to get blown by the wind. It's a typical 1-pole dead time, around about 1 second. That would be this middle condition. The arc is still there, fed by the capacitance from the healthy phases, the secondary arc condition in the middle. If things go well, after a few 100 milliseconds, up to maybe a second or so, that arc will then disappear, and we then go to the final state, You can see the switched off line is here. It's still coupled with the capacitance. There will be some voltage on here due to the capacitance, but the arc is not, has gone away. And we can, by monitoring the voltage over here, you can see this arrow shows you the voltage there. Because remember, our relay is sitting here. If we have line side voltage transformers, we can monitor the voltage here on this switched off line section, and we can see this condition, the secondary arc, using that voltage, or here see that the secondary arc has disappeared. And we can use that for a very effective way of controlling the auto reclose. Motivation. Why do we want to use the secondary arc detection? All right, we want to use it because the fixed dead time can be unnecessarily long. Here we have an example. See right on the left there is the pre-fault condition for about a cycle or so. Then you go into the fault condition there for about 3 or 4 cycles. And then you can see the trip. But the voltage, and this is the voltage on the faulted feeder, does not go to 0. Okay, because it's coupled. Initially we have the secondary arc only for a very, very short time. In the second dotted line, you can see there the secondary arc is already reset. In theory, we could have reclosed all the way much, much earlier. But typical, you hate here, it's about over, it's about a 1.2 second single pole dead time. You wait and wait and wait, and only reclose with a much, much unnecessarily long dead time. This is very common. Another problem can be obviously a metallic fault. And you can see here the same condition, pre-fault condition. Then the same first dotted line is the protection has tripped. Then the first dotted line is the fault inception. The second line, the relay trips, and you can see the voltage is 0. There's a metallic fault. It's a single pole trip, and the voltage will not be 0 unless it's clamped down via a permanent fault. It's a permanent fault. The auto recloser does not notice and will reclose here unnecessarily and cause a switch on to fault, and you have to trip again. System stress, very bad for power system stability and so on. Unnecessary, this recloser here. Secondary arc detection can prevent that. We'll see that later on. And the third one, maybe not that common. What happened on the third case over here, again a fault, but in this case, maybe it's a very long line or whatever, the secondary arc did not disappear. You can see this funny waveform here. It's got a lot of harmonics and spikes and so on, and that is the characteristic waveform of the voltage during a secondary arc. It stays on. That means the arc is not gone. So when we reclose after the dead time, the arc is still there, the fault is still there, and there will be a switch on to fault, and you have to trip again. The difference between this one and this one is, here it's a permanent fault, probably a physical damage, a conductor touching the tower or something like that, metallic fault. There, no recloser makes any sense. Here it's interesting, you have a secondary arc, it is an arc fault. If you had changed here to a 3-pole trip, then the 3-pole auto reclose would have most likely have been successful. Because remember, during the 3-pole, there's no more capacitive coupling into the switched off feeder. There's no secondary arc on a 3-pole fault. Those are the 3 conditions. So now, if we're going to apply the secondary arc detection for the auto recloser, it will improve the performance there significantly. Okay, we'll have shorter dead times, no reclosure on permanent faults, no reclosure on metallic faults, and so on. That is obviously a big advantage. In order to implement that, as I said 3 or 4 slides back, we need the voltage on the line side. So it must be a line side connected VT, and basically in the Dixie 5 routing, you route here on the circuit breaker. This voltage transformer is typically for operational measured values, but in this case, this voltage that you have routed here will also be used as your voltage to monitor the secondary arc. Okay. I think the text slide one can jump over. From a time point of view, it is not that interesting. I think I've said everything that is to be said there. You can apply this together with a classic auto recloser. The secondary arc detection will be the first cycle that you use, and you can apply additional auto reclose cycles, but they will always be the second, third coming after the secondary arc detection, if you apply that. This logic diagram just shows you on the right here, the output signals, which we'll look at in a little bit of detail later on. You are monitoring the voltage on the basically switched off feeder, and if it is too small, then it will be a metallic fault, basically no reclosure. You will always see a voltage especially after the secondary arc is extinguished, the coupled voltage over there. And the little block on the complete left there is a logical block, a multi-criteria block. We don't use a single criteria, we use multiple criteria to detect the secondary arc presence and also then the secondary arc extinction. And if after the minimum dead time has expired over here, the arc has disappeared, then you'll basically allow the reclosure because the secondary arc has disappeared. While the secondary arc is there, you give the output, I'm detecting one. And basically, if it does not disappear, then obviously you go to the top and say, cannot reclose because the secondary arc did not switch off. So we get all the information we need to practically implement this. In Dixie, it's quite simple. You go into your library, and your system library, you find there under the auto reclose the secondary arc, and you insert that into your circuit breaker where you typically would have your auto reclose function. And if you want additional cycles, you would place them at the end. So in the settings, you can see the secondary arc detection auto reclose settings are exactly the same as the normal auto reclosure. The only difference is the cycle, the secondary arc cycle has got two additional parameters which we'll look at in detail later on. It's your minimum dead time and obviously a maximum dead time. There is no fixed dead time for a secondary arc. The secondary arc only has a minimum time and a maximum time. If after the minimum time the secondary arc has disappeared, it'll reclose immediately. The secondary arc disappears very quickly, can go even quicker, but we will have some graphic examples. I'll show you those two timers in graphs just now. It's more clearly than on the text slide. That's the text definition you see there. The minimum, those two parameters, the minimum time, this is the minimum dead time after a one-pole trip. Closure will not be done before this time has expired. And the maximum dead time, as the name says, this is the maximum time if the secondary arc or whatever is still present at the end of the maximum time, then the cycle is aborted, okay? And you have a three-pole trip and nothing after that. Some graphs is always more interesting than a picture. Here you can see a nice large diagram of the voltage, only the voltage now. And you can see starting on the left, pre-fault condition, then the drop of the voltage under the fault condition, then the breaker open and the secondary arc up to this dotted line is secondary arc. And you can see the transition here from the secondary arc to this one. And there you can see it's a nice 50 hertz or fundamental frequency signal. It has got some transient in it here. This is due to other influences, but it is a clean signal. No, hardly any harmonics or anything. It's coupled from the healthy phases. Over here, it's a burning arc. Okay, that's why you see the significant harmonic and other factors we can detect. When we detect the secondary arc, you can see the alarm out, secondary arc detected. When the secondary arc disappears, you can, in theory, permit closure immediately. There is a stability time, a so-called restrike timer, just to put it. Could be that it disappears and then it restrikes here, then you don't want to release the closure. So you have a monitoring time, 150 millisecond restrike monitoring time. After that, the closure is then released. And you can have a much shorter dead time in this technique. All right. Alarms, if you're going to apply this, then it's very interesting to look at the output signal. I call them alarms, the output signaling of the secondary arc detection. You have here the three. Secondary arc is detected. No closure because the secondary arc did not go away. That would be the arc doesn't extinguish because the very long line or other influences, or metallic fault. These are the reasons for no closure. Either secondary arc did not go away or metallic fault. Metallic fault, you lock out the auto reclosure. Secondary arc didn't go off. Maybe you do a three-pole trip and a three-pole auto reclosure. That's optional, what one can do as a response to that happening. Right, and just to summarize that quickly, finally, we look at the three cases that we have. Case number one, this is a secondary arc detected. And you can see here, secondary arc extinguishes around about there, and you can see that in the alarm. Sorry, I think it's German, but doesn't matter. Secondary arc detection drops off over here, and then it permits the closure here because the minimum dead time has expired. It gives the close command. The second case over here, no reclosure. Why? Because the secondary arc doesn't go away. You can see the secondary arc condition stays, and all the way over here, the maximum dead time expires, and then no reclosure because of the maximum dead time expiring. Here, Similar situation, fault, trip, but now the voltage is very small. It's a metallic fault again, no reclosure because metallic fault was detected. Works effectively like that. The internal timers, as I said, I'll have some diagrams explaining them. We have the two timers. There's the restrike monitoring. That is a fixed timer. It's internal, 100 milliseconds, no setting required. And you have the effect here that you see a very, very short secondary arc. This is a German customer we have. He's got a strange configuration where that can happen, where you can see the fault, when the fault is cleared, there's almost no secondary arc. It's half a cycle of secondary arc. And then you have the minimum dead time needs to expire. So you don't want to then release the close basically after 50 or 70 milliseconds. You need to wait the minimum dead time. That's why we have a minimum dead time, because it could be that the secondary arc is there for an extremely short time only, and you don't want to stress the breaker by reclosing within 20 or 50 milliseconds. So typically around about 150 millisecond minimum closure time. The second example, you can see here the arc was on a little bit longer, but still the minimum closure time has not expired. So you have to, when the secondary arc extinguished, you have to still check the restrike monitoring time, and still it's too short. The closure is only given after the minimum closure dead time at that example. Here the arc is on a little bit longer. So you can see the secondary arc extinguishes, the restrike time. Now the minimum time has expired, and we can close immediately after the restrike timer. Metallic faults are a problem and blocked. Okay. I think that concludes the secondary arc detection for this presentation. If you are interested, there are some application notes and the manual explains it in detail.